This video is about complete stoichiometry problems. The important thing for this video will be figuring out where to stop your problem, right? So how many steps to do. So we have 4.9 moles of aluminum are produced, and we're looking for moles, how many moles of O2 that are made given this balanced equation. So we're going to start with our given, and that's what we'll always do with these problems, and then we'll just see how many steps it's going to take. All right, so 4.9 moles of aluminum is what we're going to start with. I'm going to set up my conversion here, and my first step will always be to take my units and drag them down. So I write moles of aluminum. I'm trying to get to moles of O2. I can actually go straight there to moles of O2, and that's because the mole to mole change, if you're changing substances and you have moles and go into moles of something else, you can use the balanced equation. You'll see that 4 moles aluminum is made for every 3 moles of O2 made. And that's it, we've got to moles O2. So we just need to punch in the calculator, 4.9 times 3 divided by 4 equals top times top divided by bottom. And we're going to get 3.675 moles of O2. And we'll round that to 3 sig figs, 3.68 moles of O2. So that one only took one step, but the next one's going to be a little different. So the next example problem I'm going to do uses this balanced equation. We have 122 grams of FeOH3 that are made in this precipitation reaction, and we're wondering how many grams of NaOH reacted. We've got our given and our unknown. We're going to start with a given, 122 grams FeOH3, and we're going to set up our conversion here. We're going to drag down grams FeOH3. It's important to write the unit and the substance, but not the number. We're trying to get to grams of NaOH, but we cannot go straight there this time. The balanced equation doesn't tell us grams of one thing to grams of something else, only moles to moles. So we're going to have to first get to moles FeOH3. Okay, so we'll have another step. We have to drag down moles FeOH3. Here we can change our substance because we can go from moles of FeOH3 to moles of the unknown, mole NaOH. The balanced equation tells us that ratio. We're not to grams NaOH yet, but we're close. So we drag down moles NaOH. Then we can go to grams of NaOH because we know how many grams are in a mole from the periodic table. Now we can fill in our numbers, and we're going to go column by column. So for moles FeOH3 to grams, we're going to look on the periodic table, and you're going to add up 1 iron plus 3 oxygens plus 3 hydrogens, and that number will go with grams. And so when you add up all those from the periodic table, you get 106.874 grams, and that's the grams in 1 mole. For the next column, we have the mole to mole ratio, and for that we look on the balanced equation. 1 mole FeOH3 is made from 3 moles NaOH. For the last column, remember, don't drag down that 3 moles NaOH. Okay, this is its own thing. You're going to look on the periodic table for grams NaOH, add them all up, and that's the grams in 1 mole NaOH. So we get 39.998 grams in 1 mole NaOH. And from here, we want to cancel our units just to make sure that we've got the right unit at the end. Oh, good, we're left with grams NaOH. So you just punch in your calculator, top times top times top times top, divide by bottom, divide by bottom, divide by bottom. So 122 times 1 times 3 times 39.998, divide by 106.874, divide by 1, enter. When you do that, you're going to get the grams NaOH, and that's 136.98 grams NaOH. I'm going to round that to 3 sig figs, so 137 grams is the answer. And remember, for this one, you did have more steps than last time. So every time on stoichiometry problems, you just need to figure out where can I go next and keep going until you get to your unknown.